The second lecture is for the sets, basic concept of sets. A set is a collection of objects whose contents are clearly determined. So this is a collection where we have some objects, the collection of objects, and these objects are clearly determined. Elements or members of the set are the object in a set. Okay. The order in which the elements of the set are listed is not important. Example of a set. So this is a set A, which is 2, 4, 6, 8, and this is the set of positive even numbers less than 10. Okay, so this is the set of positive numbers, positive even numbers less than 10. And a set is, the name of a set is a uppercase letter. Okay, and we put the elements, or we put the objects with comma inside the braces. Okay, so that's how we represent a set. Okay, so there can be any set. We can make any set of any object. We put the objects in braces and we put a comma in between those objects, and we give a name with a uppercase letter. Okay, question is, find the set of days of the week and use roster method to list the members of a set. So when it says a roster method, we need to list all the members. Okay, so the 7 days of a week, we can put a name like a W is the name of set. Okay, so this is the name of set. Now we put brackets and then write all the names of 7 days. So Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. So this is the set of 7 days of a week, and this is in roster method. This is in roster form. Okay, so in the roster method, we write all the members, and we put a comma. We put comma in between those objects. Now write a word description of a set. Now this set is given in roster method. Now we need to write it in the word description. Okay, so we can write it this way. P is the set of, now what is this? Washington, Adams, Jefferson, Madison, Monroe. These are the president, first 5 president, 1, 2, 3, 4, 5 years, first 5 president of United States, right? So we can write P is the set of first 5 presidents of United States. So we can write a set in roster form. We can write a set in word description. Okay, so we write the word description. We can change from roster to this to word description, or from word description to roster. The next question is, write using the roster method. Now we write in the roster method. The set C is the set of US coins with a value of less than $1. So we can put C, the name of the set, and we write all the coins which are less than $1, right? So penny, nickel, dime, quarter, and $half. Okay, so we get $half too. So this way we can change from a description to roster form. Now set builder notation. Set builder notation is something that we write in this format. So we put a braces, and then we write X. Okay, so we write X to represent any object, and then we specify, we put a slash, we put a line, and we specify what is X. Just like writing in description method, but in little different way. So we write, it looks like a roster method, but we put a description to specify what is the object. Okay, to specify the object. So X says that X is a day of the week. Okay, so if we write it like this, then this represents the same set as W, because in W we write Sunday, Monday to Saturday. So we write this way. This is called roster method, and we write this way is called set builder method. Okay, so this set is set W. So W is the set of X such that. So this line is called such that. Okay, so this represents as such that. So this specifies what is X. This explains what is this value. So X is a day of 7 days of a week, means X is these. Okay, so X are these things, Sunday, Monday through Saturday. So we write in set builder notation, we write the set in this format. And we read this as W is the set of all elements of X, such that X is the day of the week. We read it like this. The vertical line, before the vertical line, the variable is the variable X. Before the line, there is a variable X, which represent an element in general. And then after the vertical line is the condition that X must meet in order to be an element of the set. Okay, so this is just the description of what we write in here. Okay, now the next thing is converting from set builder to roster notation. Express the set A such that A is the set of X, such that X is a month that begins with the letter M, using roster method. Now we need to write in roster method. The answer is A equals to, now we write all the month that it begin with M. So we know that March start with M. So March and May. Okay, so these two months start with M. So this is in the roster form of this set builder notation. Okay, now the next thing is empty set. The empty set, which is also called a null set, is the set that contains no element. Okay, the empty set is represented by either empty braces or this symbol phi. This symbol is called phi. Okay, so if there is just phi with no braces, then this is an empty set. Examples of empty set. Example of empty set is, this is example, not examples. Okay, set A is a set of all number less than 4 and greater than 10. So there is no any number which is less than 4 and greater than 10, right? So there are some numbers in between 4 and 10, but there is no any number that is less than 10 less than 4, and also greater than 10. So we can find a number which satisfies both conditions, like which satisfies less than 10 also and greater than 10 also. We cannot get any set like that, so it is an empty set. Question is, which of the following is empty set? 0, this is not, this is no, because there is an element 0 inside the braces, so it is not empty set. It has one element. Okay, just 0, no, because this is not a set, because we don't have it doesn't have the braces. No, it is just a number. To be the set, it has to have these braces. Okay, so if there is no braces, it's just a number, it is not a set. X says that X is a number greater than 10. Yes, there are some number, wait, what is the question? What if the following, which of the following is empty set? Right, so this is not empty set, this is not empty set, this is not empty set, because there are some numbers greater than 10, right? So this is not an empty set, so we can write no. Now this is X such that X is a square with 3 sides. We can't get a square with 3 sides, because a square has to have 4 sides. Okay, so it doesn't have, we don't get any square which has 3 sides, so this is empty set. Yes, this is empty set. Okay, now the notations of these and these notations. Okay, this notation means it belongs to certain set. A member belongs to the set. This notation doesn't belong to the set. Okay, so this means it is the object is in the set. This means the object is not in the set. Okay, so this question is, determine whether each element is each statement is true or false. R belongs to this set. Yes, R belongs to this set, so this is true, because when you see these 3 dots, this means that we get A, B, C, D, E, and it goes up to G. So R is there. So R belongs to this set. Okay, so this is true. 7 doesn't belong to this set. There are no 7. There is no 7 in the set. So 7 doesn't belong to the set. So this is true. Okay. A belongs to AB. Now these symbols are for an object. These symbols are not for the entire set. Set A is the set because we have the braces and A, so this is a set. So this is, we can't apply this symbol for a set. We need this symbol for object, but not for the set. So this is false. Okay, so if there is C, if it was just A belongs to AB, then this is true, because A is an element which belongs to the set. But here A is a set, this is a set, and set doesn't belong to the set. Okay, so it is a different set, it is a different set, so it is false. The set of natural number is written as n, 1, 2, 3, 4, 5, 6, any number that start with 1 and goes like 2, 3, 4, 5, 6 and so on. This set is called the set of natural number. Okay, so this set is the set of natural number and we represent by n. Express each of the following set using the roster method. Now we list all the members of the set. Set A is the set of natural number less than 5. So set of natural number less than 5. So A equals to, so you can write the natural number less than 5. Natural number starts from 1. So 1, 2, 3, 4. Okay, because it says less than 5, so don't include 5. So just 1, 2, 3, 4. So this is the set, okay, of natural number less than 5. Set B is the set of natural number greater than or equal to 25. So set B is greater than or equals to 25. So it starts with 25 because it says equal to 25, greater than or equals to, so we start with 25, 26, 27, and so on. Okay, so this set because it says greater than, so it keep going, right? So this is the set B. Okay, so let's go to the next page. Okay, C is the set of x such that x belongs to n. That means x is a natural number and x is even. So set C has to be even number. It belongs to n. 0 doesn't belong to n because n start with 1, but it has to be even. Okay, so natural number which are even. So 2, 4, 6, 8, and so on, because we can't list all the natural numbers. It is infinite numbers. Okay, there are infinite numbers, so we can write 3 dots and we can stop. Set D is x which belongs to n, means the natural number, and x is less than or equals to 100. So the set is a D which starts from 1 because it belongs to natural number. So start with 1, 2, 3, and keep going. Okay, and less than or equals to 100, so it goes up to 100. So we can write 99 and 100 and stop. So this set is the set of natural number x belong to n and x is less than or equals to 100. Okay, so here the numbers are less than or equals to 100. So that's how we write these sets. So we write these set builder notation into the roster notation of any set, of a set. Now the next thing is the cardinal number. The cardinal number is a number that counts how many elements are inside the set. Okay, so if A is 7, 9, 11, 13, so there are 4 numbers inside set A, so the cardinal number of A is 4. Okay, so we represent the cardinal number with the symbol NA, N and inside A. So this represents the cardinal number of a set, NA. So A is this, so the cardinal number of set A equals to 4. Cardinal number is 4 because there are 4 elements, 4 objects. B equals to 0, there is one object inside the set, so cardinal number of B equals to 1. C is 13, 14, 15, 22, 23. So there are 3 dots, so be careful, you need to include all the numbers between 15 and 22 because of that dots, right? So you count 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So there are 11 numbers inside the set C. So cardinal number of C equals to 11. Okay, so that's how we find the cardinal number of a set. We count the elements, the number of elements. Equivalent sets and equal sets. So there are 2 types of equivalent and equal sets. Equivalent sets is, it just counts the number. If the 2 sets have same number of elements, like one set has 4 elements and another set has 4 elements, they have same number of elements, they are equivalent. But to be equal sets, they have to have the same number of element and they have to have the same elements to be equal. Okay, but here is equivalent. So let's see, the equivalent set A is equivalent to B, means that the set A and B contain the same number of elements. Okay, so cardinal number of A and cardinal number of B has to be equal. And for equal set, a set A is equal to B means that the A and B contain exactly the same element, regardless of order or possible repetition of element. Okay, so the thing is, the two sets, if they have same number of elements and same elements, but those elements can be in different places. Like one set can have 1, 2, 3, 4, and the other set can have 4, 3, 1, 2. They have the same element, right, and the same number of element, then they are equal sets. Okay, so equivalent is just the number count is same, but equal is they have to be the same element. Okay, so these are equivalent set and equal set. And here is a finite and infinite set. Finite set is the set where we can count how many elements are there. That is the finite set. And infinite set is the set which we can't count. Okay, so if the set has a 0 element, or if it is a finite number, the cardinal number is a finite number, then it is called a finite set. But if the element is not a 0 or infinite number, then it is called an infinite set. Okay, so all this depends on the elements or the objects that you have. If you have finite object, this is called finite set. If you have infinite object, called infinite set. Okay, now here is a question for equivalent set and equal set. Determine which of these statement is true or false. Okay, so these two sets are equal. Are these two equal? Because it says an equal sign in between. Is this true? So it has 3 elements, right? So 4, 8, 9, and it has 3 elements, 8, 9, 4, and also they are same. These numbers are same. These numbers are same. So yes, this is true because these are equal set. And these are not equal because 1, 3, 5 and 0, 1, 3, 5. So there is one more element in here, so which is not in here. So this is false. It can be equal set. Okay, so that's how we find the equal and equivalent. These are not equal, these are equal, these are also equivalent, these are not equivalent. A set A is a subset. Now another thing is a subset of a set. Subset. So when A is a subset of B, means that A is a smaller set which fits into B. So all the element from A is from the set B. So they have like, just remember, like A is a smaller set and B is a bigger set, and A can completely go inside B. Okay, so A has all the elements which are also in the set B. So if every element in set A is also an element of set B, then A is called a subset of B. And we represent subset with this symbol. This symbol. Okay, so we write, question is write subset or not subset in the blank to form the true statement. So A and B. See, A has 1, 3, 5, 7 and B also has 1, 3, 5, 7, and B is a bigger set and A is a smaller set, and all element from A is also from B, right? So A can fit into B. So there is a A inside B. So if A is inside B, then this is a subset. So A is a subset of B. Okay, so this is the thing, this is the concept. Now the subset, there are two types of subsets. Proper subset, well, just proper subset. Let's see just proper subset. A proper subset is if A is a smaller, just like this, if here A is a proper subset of B because A is smaller than B. If they are same set, like if both are equal, then one is the subset of the other and the other is the subset of the other, right? So because one can fit into the next and the next one fit into the one, so both can go inside of each other. So in that case, both are subsets of each other, and then they are called improper subset. If it is a proper subset, then A is a smaller set which can go into inside B. So if A and B are the two sets where A is a smaller set, B is a bigger set, and A can fit into B, then it is a proper subset. If they are not equal, see here it says if A is a subset of B and A and B are not equal, then A is called a proper subset of B. And the proper subset is denoted by this symbol, just this symbol. This is a subset, this is proper subset. Okay, so if it is a subset, you can write this and you can also write this, because in this case you could write A is a subset of B but proper subset. Okay, it just looks like a C. It is not a C, but it is a long, it is a symbol. It looks like C. Okay, so this question is write the subset or proper subset or both to form a true statement. A is a person and X equals to X, where X is a person and X lives in San Francisco. B is a person and lives in California. California is bigger than San Francisco, and San Francisco is inside California, right? So here A is inside B, so A is a subset of B, and because it is a smaller set, it is a proper subset of B. Now A is 2468 and B is 28646. So just like I said before, these are equal set, so A is a subset of B. You can write B is a subset of A, but these are not proper subset, these are improper subset. So A is the subset of B, but we can't write this symbol because A is not smaller than B. Okay, so this is the basic idea about sets. We need few more topics from set, so that I will cover in the next video. Okay, I'll see you later. Bye.